So this is section 4-4. This is just, we'll just call it part 1. And this is just graphs of sine and cosine. Graphs of sine and...
Can we turn out the light?
Turn out the lights, yeah.
Thank you.
Okay, sorry. And graphs of sine and cosine. That didn't help much. Is that shade? Ah! Oh my God. So graphs of sine and cosine. So you already know that, you should know that y equals sine of x. It's a graph that you did a little exploration on it. Let me see if I could draw a straighter line than that. Going like this. And if I look at a unit circle at the same time, we'll kind of put a little unit circle somewhere here, 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 here. That's pretty good. And this is the point 1, 0. This is the point 0, 1. This is the point negative 1, 0. And this is the point 0, negative 1. I think I talked about this already. But if, so sine of x is just the graph of y, what y does as x moves around this unit circle, right? In the book, they'll say find the sine of t or something like. So in the book, they use t, but now they're using x, which is a variable. So as I move around this unit circle, around and round and round, I get various values. So the sine of 0 is 0, right? So I could have put a point here at 0, 0. Then when I get over to pi, or to 2 pi, what's the sine of pi as I get here? What's the sine of, it's also 0, right? What's the sine of 2 pi if I go all the way around the circle? It's also 0. So now that's not a very interesting graph, so I got to figure out some points that are in between those 2 points, okay? So maybe this point up here, which would be halfway between 0 and pi, what would be halfway between 0 and pi? Pi over 2, but what's the value of sine? That's right, Matt, 1, right? So it goes up to 1 here as I get to pi over 2. When I go around the unit circle some more, and I get to 3 pi over 2, where does my graph go? Negative 1, okay? And then those other points, like if I were to graph come over here somewhere to like pi over 6 or something like that, pi over 6, which would be about here, I would get square root of 2 over, no, square root of 3 over 2?
Yeah.
Square root of 3 over 2, which is, square root of 3 over 2 is 1.7 divided by, so it'd be like 0.8 or something like that, okay? So that would be over here somewhere, okay? And so in any case, what you end up getting is a graph that goes up and down and up and down, and it goes on forever and ever, okay? Because it's a periodic function, and I could go around that unit circle as many times as I want to go, and I get this thing that looks like that. Yes? Okay. Y equals cosine of x looks a little bit different, okay? Y equals cosine of x. You still base it off the unit circle, but instead of graphing the the y coordinates, we're going to graph the x coordinates. So let's see if I can make a graph of y equals cosine x. I'm getting better at this, okay? So if I were to graph y equals cosine of x, and I go from 0 to 2 pi, so if this is pi and this is 2 pi, where does it start? When, right? Do you understand why it starts at 1?
Yeah.
Because the cosine of 0 radians is 1. So it's kind of weird, but what I'm graphing here is the x coordinates on the unit circle. So it starts at 1. I should use a different color dot, okay? And then at, if I were to graph pi over 2, what's the cosine of pi over 2? What's the x coordinate here?
0.
0, so you go through 0 there. When I get to pi, what's the cosine of pi? Negative 1, so I go down to negative 1 there. And then at 3 pi over 2, it's going to be 0 again, okay? And then at 2 pi, it's going to go back to 1. So what I end up getting when I graph the cosine function is something that looks kind of like, this might be hard for me to draw my Mobi, but like this. And back up, I messed up. And goes like that, except that's one period of cosine, and it doesn't really look like a parabola. It's actually turning directions here, so I didn't really draw that very well, but if I continued this on, and it does go on forever and ever, it looks just like a periodic function. It's easier for me to draw here. And it goes on forever and ever and ever like that, okay? And usually I will ask you to sketch 2 periods of it. So this would be like negative pi over 2 over here. This would be like negative pi over here. This would be negative 2 pi over here. Okay. Can anyone tell me how sine of x and cosine x might be related to each other? Go ahead, Matt.
Aren't the y values, like, isn't there not 1?
Yeah, they have maxes of max of 1 and a min of 1. But if I took this graph, how could I move this graph to make it look like this graph? Brian?
Then go plus pi halves.
Yeah, I just move it this way, pi over 2, right? So sine of x, if I took sine of x and I moved it this way, how do I move something this way? I add, right? So sine of x plus pi over 2 is going to be equal to cosine x. And if you put both of those things into your calculator, those things would be the same. How could I shift cosine x to make it look like sine of x? Backwards or forwards?
Forwards.
I'd have to move this forwards, right? Because how far would I have to move it forwards? Yeah, because if I took this point and moved it up to here, right, it would look just like this one. Do you see that? Okay. So I'd have to take this point, move it up here. So then cosine x, so you could say that cosine of x minus pi over 2, because that's how you move something forwards, right, is equal to sine of x. Okay? And not coincidentally, those are also co-functions, so the sine of something minus pi over 2 is equal to the cosine of something else and vice versa. Okay? Yeah? All right, so now we're going to talk about this thing here. Let me get a new piece of paper. This thing just has endless pieces of paper in it. So if I do have a sine function or a cosine function, they can, what you discovered the other day is they can stretch. They can go up high and they could go down low. So you could have something that goes like this. Ooh, that's pretty good, okay? And this thing here, the distance, where'd my workspace go? There it is. Oh, go away. The distance from here to here, okay, or the distance from here, they should be the same, but I did it kind of quick. That thing is called the amplitude, okay? The amplitude, and in the equation, y equals a sine or cosine x, okay? The absolute value of a is equal to the amplitude, okay? And also, the maximum minus the minimum divided by 2 is equal to the amplitude, okay? So say, for instance, I knew that this point goes up to, I don't know, this point, say this is 5 up here, and the bottom down here goes down to something comma 5. and the bottom down here goes down to something, comma, negative 5. What would be the amplitude of this function? What would be the amplitude of this function? 5, right? Because it's 5 minus negative 5 makes 10 divided by 2 would give you 5. So this might be the graph of y equals 5 sine of x. How would I flip that upside down? You guys remember from the lab? What's wrong? You can't see that, Hunter? You're looking, what would this do to it? What if I did y equals negative 5 sine of x? You did this in your lab. What does that do to your graph? Flips it upside down. So y equals negative 5 sine of x is going to take it and it's going to flip it this way, right? Going to make it go like that. So that one would be that one would be that one. Who had a question? Did you have a question? Brian? Okay. So that's the amplitude. That's not very hard, right? So could you do a problem like graph y equals negative 3 cosine of x? If they asked you to graph that, could you do it? Okay, let's just sketch it. Okay, and a lot of times they'll say sketch 2 periods of the graph of y equals negative 3 cosine of x. Where would that start?
At the bottom.
It would start at the bottom, down here at what point? At 0, negative 3, right? Having negative 3. And then it would go up and down, and it'd do that in 2 pi. We'll talk about the period in a minute. And then it would go up and down, and that would be one cycle of it. And then you would continue it if you want. If they said graph 2 periods of this function, and you'd have to go up and down again, maybe on the other side or in front of it, or something like that. Okay? Questions? Okay, Theo, would you mind closing your computer right now? Thank you. Okay? So, so the period is defined as, okay, how long it takes to complete one cycle, okay? And usually they talk about that in radians, okay? So what is the period of cosine of x? How long does it take before you go up and then back down? 2 pi, right? So, so the period is how long it takes to complete one cycle. So for sine and cosine, the period, just plain cosine x and sine x, the period for y equals sine x or cosine x, the period is equal to 2 pi. But when I put numbers in front of these things, like y equals sine of 2x, you were supposed to play with that in that lab that you did the other day. What does that do to your function? Do you remember? Doesn't stretch it. You're going like this. What does it do to it? Sorry, Brody.
It makes the period just pi.
It makes a period pi. Very good. It shrinks it by, or it makes it go twice as fast. Okay? So this number in front, which they call b, okay, that number makes it go whatever that number is times as fast. Okay? So it's going to be, it does 2 cycles, basically. It does 2 periods in 2 pi radians. So if I were going to graph y equals sine of 2x, I might put pi over here, and then I could put like, what would be the halfway point, pi over 2. So I could show you that this y equals sine of 2x on the same graph would go up, up, and down, and up, and down, and up, and down. Not very accurate. but it would do 2 of those in 2 pi radians, right? But there's a formula. The period is equal to 2 pi divided by b, and b is equal to 2 pi divided by the period, right? So a lot of times they'll give you, you'll look at the equation and it'll say sketch the graph, and you'll have to figure out, well, what's the period of that graph? So if I were to plug in 2 in here, I get that the period is 2 pi divided by 2, so the period of sine of 2x is just 2, right? But if I have something weird, okay, do you get that? Did I go too fast? No? You look confused, man.
How'd you just get 2?
How'd I get, oh, I'm sorry, you're right. So the period is pi. Sorry, period is pi. Thank you. Right, sometimes I just say stuff. So, going on a new thing, like if I had something like, new piece of paper. Where's my paper? If I had something like sketch y equals sine of pi x. And you go, I don't know how to do that, okay? Well, in your equation, y equals sine of bx, this number is b, right? And remember that b is equal to 2 pi over the period, and the period is equal to 2 pi divided by b. So if I plug in pi in here, what do I get out? 2, okay? So the period of this is equal to 2. 2 what? To be 2 radians, okay? So what that means, if you were graphing this particular function, it's kind of easy to graph because there's no pi's or anything like that on the graph. It's just, here's 0 radians, 1 radian, 2 radians. So there's 1, 2, okay? And it does an up and down in 2 radians. So it's going to go up like that, down like that. What would be this point? 1.5 radians, right? 1.5, how many radians would this be? 0.5 radians, okay? And you get that, the way that works? Okay. So now, sometimes they like you to go backwards. Did I do that? Oh, I didn't talk about the vertical shift yet. Sorry, got to teach you this stuff. So, vertical shift. You guys, what did I just do? Don't do that. Don't do that. So, vertical shift is if I have y equals d plus sine or cosine. So I'm going to just write cosine of x. D is the vertical shift, up or down. You kind of realize that in your lab that you did the other day? So if I did like y equals 3 plus cosine x, okay, the way I would graph that is I would make an xy axis. I would start where, the way I do it is I graph this thing, y equals 3, okay? I'm going to make that a dotted line. I'm going to make it a red line going like this across, okay? So this is the line y equals 3. And then how many units above 3 would that graph start? Y, it would start at 1 unit. So it'd start up here at 0, 4, right? And it would go down to what? If it goes 1 above, it would go down to 2, right? And then it would do this whole thing again in 2 pi radians. So this graph, and probably want to put the low point here since it's a cosine function, and the high point here, and it would look something like this. I should have drawn it better, but that's one period of y equals 3 plus cosine x. This line here, okay, I call it the midline, okay, midline. And the way you could find the equation of that is by going the maximum y equals maximum plus the minimum divided by 2. Okay, so if I took the highest point and the lowest point of my graph and I divide it by 2, that gives me the equation of that line. That's the middle line, and that helps you graph the function. Okay. So whereas with the amplitude, it's max minus min divided by 2. To find the equation of the, I call it the middle line, or the vertical shift, right? Vert shift, it's the max minus the min divided by 2. Yes, ma'am?
What would it be if it was like 3 times cosine x?
We're getting to that. So if it were like a 3 in front of here,
Yeah.
then it would, so that's a good question. If I put a 3 in front of here, right, instead of starting at 0.4, it would start 3 units above that, so it would start at 6.06, right, because it's stretching and it just go, and then it would go down here to, let's see, 3 below 3, so it would go down to 0, right, and then it would go back up to 6, yeah?
And the division would shorten it,
The division,
would shrink it, likewise.
yeah, if you did it like a 1/2 in front, then it'd shrink
Yeah.
it, yeah. Brian?
Wait, you find the midline is max plus mid?
Yeah, it's like the average, right? Because
Yeah.
you're taking the average of the top and the bottom. Here, we're going to do one where you have to go backwards, okay? And then I'll be done talking for a while, I promise, okay? I think you need a joke. Do you need a joke?
We need a joke.
We better pause for station identification. So last thing that you might see is a graph, and you have to come up with the equation. So, and that's where people have, well, I don't think they have that much trouble. Some people have trouble. But you guys are the gifted class. Let's not make that a dotted line. Let's make that a solid line. We can even put arrows on the end of it to make it look really good. Okay? So here's a line. Here's another line. Here's some function, okay, down here, and this function is squiggling around, kind of like this, okay, and it goes from here to here. It takes pi to go here. It takes 2 pi to go here. This is the point -1. This is the point -5, even though it might not be to scale. And then I say find the equation. Find the equation of the trig function. Okay? So using all that info that I just gave you, you can figure it out. Probably the first thing you want to decide is whether it's a sine or a cosine function. Sine or cosine?
Cosine.
It can be either, but so far we're not shifting it left or right. We're just, so if it's, so which one? So then it's going to be a cosine. So it's y equals something with a cosine in there, right? Cosine. Now I got to figure out, I think the best thing might be to first find the vertical shift. So all I have to do is go the maximum. What's the maximum at? -1, okay? Plus the minimum, what's the minimum? -5, right? Divided by 2 is going to give you the equation of the line that cuts it in half. So what's that? Y equals -3 is going to be the line that cuts this thing in half. Okay, so I'm going to do, so there it is. Okay? So the equation of this thing here is y equals -3. Now I gotta find, so that in the equation, where's that gonna go in the equation?
Minus
Yeah, it's gonna start with a -3, okay? And like, normally we put those things at the end, but you don't wanna take the cosine of something and then have -3, because you might be taking the cosine of something -3 and it's gonna get confusing. So they wanna stick this out in front, okay? Then it's gonna be plus, but we gotta find an amplitude. How much is this thing stretched? You could just look at it and tell me how much is it stretched from -3 to -1. 2, right? So you could have also used that formula and go the max minus the min divided by 2, which would have given you -1 plus 5, right? Which is 4 divided by 2 gives you 2, right? Or you could just look at the graph and say, oh, since this is -3, that's got to be 2 up to there. So there's going to be a 2 up front, and now all I have to find out is b, and b is equal to 2 pi divided by the period. Well, what is the period of this function? How long does it take to complete? It's pi, okay? So I'm going to go b is equal to 2 pi divided by pi, which is 2, okay? And that goes in front of that, and that would be the equation of that graph. Pretty cool, huh?
Yeah.
How do
Okay.
you know whether it's cosine, sine?
Well, I could have called it a sine if I started here,
Yeah.
right? But then I'd have to shift it backwards, which we'll work on tomorrow. I want to show you how to do this on your calculator, okay? Because it's kind of cool, and you should know how to use your graphing calculator to do this, okay?
Like, Mr. Leo, what does the B stand for again?
B is, it's 1 over the period. B is how
B is
many,
2.
it doesn't really have a name, but it's how many cycles it does in 2 pi radians, right?
Yeah.
How many ups and downs. You're done? Okay, thanks. But I just want to show you how to put this into your calculator, because there's a few little things that you got to know. And so I think I did this with the last class, so it's probably in there already. No, it's not. No, it's not. Okay? Just to show you that I'm right. Okay? When you're setting up your graphing calculator to do stuff like this, and when you take a test, you'll have both a calculator and a non-calculator thing. So I'm going to clear everything out. First thing that you want to do is set up, make sure that you are in mode, okay? And make sure you're in radians. If you're not in radians, you're going to get like a flat line or a really fast moving curve or something like that. So make sure you're in radians. And then you want to set up your window so that, and I hit my window so that it goes from -2 pi to +2 pi. So that should show me a reasonable domain of reasonable amount of x values. So I just go -2 second pi for my x min, and then I go to 2 second pi for my x max. And then if you think about your graph for this one, since I know it goes down to -5, I'm going to set my y min at -6, and I'm going to set my y max. I just set my y max at 1 because I can see from my graph that it's not going to go above 0, right? And then I put my equation in, okay? And I'm going to go -3 plus 2 cosine of 2x. The other thing, make sure that you enclose that 2x in parentheses. Otherwise, it's going to take the cosine of 2 and multiply that by x, which is going to give you a straight line. Well, you can't take the, oh yeah, and it's going to give you a straight line. So then if you hit graph, I'm going to, just for the heck of it, I'm also going to graph y equals -3, okay? And so now I'm going to hit graph, and if you did it right, there's your, so this is my graph on my picture isn't to scale, but you could see that it kind of looks like what I said it would look like. There's the line, and if you hit trace, okay, you can see that there's a point 0, -1, just like we said it was. And then if I move down here can tell you that this is the point pi, no, that's pi over 2, right? So 1.5 something, and then it should take pi radians to complete one cycle, which that looks like about pi, right? Okay, so that's how you do it on your calculator. That's kind of cool, right? Okay, some people don't think that's cool. But that's okay. You don't have to think it's cool. You just have to do the work and pass it.